So in this video, we are going to see about how to solve load flow in MIPOWER software. So we know how to solve load flow manually. So with this software, we are going to draw the buses, loads, generator, all the things, and we are going to solve load flow analysis for n number of bus system by using MIPOWER software. So this is the problem what we are going to solve for MIPOWER. So in this problem, we are considering 5 buses. While if you are using MIPOWER, you can draw for n number of buses, then you can compute all the load flow parameters. We are considering 5 bus system with the values shown in the picture. The impedance and line charging and bus voltages, generation voltages for that problem is shown in this figure. So the values like from buses, 2 buses, like from bus 1 to 2, 1 to 3, 2 to 3, like that. They have given impedance values as well as line charging values. Similarly, for each buses, they have given bus voltages as well as your load generation or then load power also they have mentioned. So just note down this data. Now we are going to see how to open MIPOWER software. So once if you open, you can see MIPOWER. So a tree type structure. So if you double click that, it will open. So it will ask password. So there will be no password for that. So just click OK button. Then it will shows 3 things. So create user account, modify user account, and MIPOWER. So click MIPOWER icon. So it will verify the license. So again it will ask various access levels. So just click OK. Just select super user level. So you will get first page of your MIPOWER. So you can see MIPOWER computer aided power system analysis. So from this software we are going to do it. So we have to draw the buses. So in order to draw the buses, just double click this power system network editor. Once if you click, it will open a network editor. Here we are going to draw all the buses. So before drawing anything, we have to configure the database. So first, in order to configure the database, just click database button and configure. Then you can find the database name, then click browse button. So here you cannot type in the database name, so you have to click browse button. So it will show you one window. Just type the name, say example ER011. I'm taking the file name, so click open. So once if you do that, that database link will automatically comes. Then click connect button, then proceed OK. So then we have to configure some of the things. So first it will ask general information, where we have to choose power system library and standard relay libraries. So we are going to do only load flow analysis. So it is enough for us to use only power system libraries. Second, if you choose second tab, it will ask different voltage levels. Some of the standard voltages are available. If we want a specific voltage, say example 100 kV. So if we want our specific voltage, we have to include that voltages, right? Then click electrical and currency information. So we have to choose base MVA and base frequency. So if you look at the problem, they will give the base MVA and base frequency. So if you look at the problem, they have given 60 Hz as frequency. Based upon the base frequency, we have to choose. Then breaker ratings. So we are not going to use the breaker. So then click OK. So once if you complete this setup, so this page will come. So we have to check whether databases are configured or not. So for that, just click database and you can check the connect option will be disabled. Now only we can sure that our network editor will be configured to database, right? Now we have to draw the buses. So in order to draw the buses, we have to draw clearly. So first we have to put grid lines. So near the icon picture, you can see toggle grid lines will be available. Once if you click, you will get the grid lines in the network editor window. So first we have to draw buses. So in our problem, we have 5 buses with voltage rating of 220 kV. So for taking the buses, check the right corner. The first icon will be bus. So once if you click that, you will get the voltage rating of buses. So in our problem, we have 220 kV as given thing. So select 220 kV. So for bus 1, it will be 220 kV. So the bus ID will be 1, bus name will be bus 1. Just click OK. So once you have to draw the bus as like paint, right? So once if you do that, you will get bus data, then click OK. Then another window will open, so which will require which will source the data of that particular bus. So just you simply click update record, then it will be closed automatically, right? So once after completing this thing, you will get so bus 1 number above your bus. Now we have to draw bus 2. So same procedure as like paint, we have to draw a line. So it will ask for bus 2. Click OK. Then it will source the bus data. Click update record. Right? So you will get bus 2 yes here. Then we have to draw bus 3. So you have to draw the buses yes like in the given problem. So if we interchange the buses, the answer will differ. Yes, like if we interchange the bus numbers, the computation while solving that also differs. So the values of voltages and the power generation will be differed if we choose or if we wrongly configured a different number of buses, right? So you just draw the buses yes like in the figure, right? So you have to draw bus 3, then click OK, then update record. Then you have to draw bus 4, click OK, then update record. then bus 5, click OK, then update record, right? So once if you complete the drawing of buses, we have to draw the transmission line. So in order to draw the transmission line, so in our problem, all the voltages are 220 kV. So we have drawn all the buses of 220 kV. Now we have to draw the transmission line. So check the right corner. So at the center, it shows transmission line. So just click that transmission icon button and just come under the to the network editor. We have to paste that buses or transmission line. So in between the buses we have to click. So first I am going to draw a transmission line between bus 1 to 2. So just I am clicking here. So it will ask from bus. So my from bus will be 1. So just go to that and double click the left mouse button. So it will show you 2 bus. So just double click at the 2 bus button. So it will ask element ID. You can see here it will show L type line. So kilometer will be 0. So just click OK. It will show line and cable data. So in order to do the cable data, so go to structure reference number and click anything. So this will be an standard one which will be available in the network editor. So we have to choose any structure reference number, then click transmission library button. So once if you click transmission library button, another one library will open. So that will show you the line and cable library where we can add our resistance and reactance values. So for that, so just click add record button. So that is plus mark which will be available at the left corner. So just check the reference number. First it will be 1001. So name will be something. So once if you click that plus button, you can see that number will be varied. We can able to change the name of that line. So I am considering line 1 to 2. I am changing the name. So here they have given the values. So in the problem, if you look at line resistance, it will be for line 1 to 2 0.02, and reactance it will be 0.06, and B by 2 the value will be 0.03. Then they have in our problem they have not mentioned the values of zero sequence thing, and thermal rating we have considered it will be 100 MVA. So enter the values based upon the given problem, then click update record button. So once if you click update record button, this plus symbol will activated. So that means you have saved that record. Once you complete this thing, so just close this window. Now once again you go to structure reference number, click that icon, So once if you scroll down, we can find what we have saved now. So I have saved the line name 1 to 2. So that will be available in that structure reference number. You can choose that. So once if you completed structure reference number thing, so just go to derated MBA. So the base MBA we have chosen will be 100. So just change it as 100. Then you have to click update record. So once if you update record, you can see in the picture the line will be named as the name what we have given earlier, and it will be changed to 1 kilometer. Now we can see this will be correct. Suppose if the line shows 0 kilometer or any other name, the transmission line what we have drawn is wrong, right? So once again I'm going to draw a line from 1 to 3. So for that, so I'm going to click transmission line button. Going to the editor window, I have to click where the transmission buses are placed. At the center I will click, so it will ask, so from bus, so just double click, left double click, then it will shows to bus, then again double click, it will ask element ID, so it will be give OK, it will source line or cable data. Once if this line or cable data opens, what we have to do, just click structure reference number, choose any one, then click transmission line library. It will source another window, so the data of line and cable library. Click add button, so your number will varied, so we can change the name. So line 1 to 3 I am choosing. So for the line 1 to 3, so in the problem if you look at, the value given will be R value is 0.08, L value is 0.24, B by 2 value in the problem they have given 0.025. All the things remains 0 because they have not mentioned. So the thermal rating we have chosen 100. Once if you complete entry, click update record, right? So once if you click update record, close this window, go to the structure reference number. If you find line 123, so just choose that, just change the thermal rating as 100, then update record. So you can check, so it will be line, it will be of 1 kilometer. So line 1 2 3, it will be of 1 kilometer. Now once again I am going to draw a line, so from the buses 2 to 3. So I am going to draw a line from bus 2 to 3. So for that I am going to click again transmission line. So I am placing line, so double click, left double click, then it will ask to bus, again at to bus, left double click, so you will get element ID, click OK. So this thing will come, go to structure reference number, choose any one, and click transmission library. Once if your transmission library is open, click add record. So just rename, it will be line 2 to 3. So just change the values as shown in the figure 0.06, 0.18, b by 2 they have mentioned 0.02, 0 sequence resistance they have given nothing, so we have taken 0. So we have chosen rating as 100 MVA. So change thermal rating as 100 MVA, then click update record. Once if you do that, close this window. Again go to structure reference number. You can find line 2 to 3. So choose that, change the rated MVA as 100, then update the record. Right, so you can see line 2 to 3, it will be of 1 kilometer. So now I'm going to draw a line which will be from 2 to 5. So for that I'm clicking transmission line. So at center I'm clicking. So from bus double click, at 2 bus double click. So it will source element ID, click OK. Again go to any some value, structure reference number, you can choose anyone, no problem. So click again transmission line library. You have to add new record. You can change the name. Name will be line 2 to 5. In the problem they have given for line 2 to 5, R value will be 0.04, X value will be 0.12, B value will be 0.015, remaining things 0, thermal rating 100 because we have chosen base MVA as 100. After filling, click update record button, close this window, go to the structure reference number, you can find line 2 to 5. So here change MVA as 100, update your record. So you can find line 2 to 5, it will be 1 kilometer, right? Then I'm going to draw a line, so which will be line 3 to 4. So from bus double click to bus double click, it will source element ID. So for this click structure reference number, choose anyone, click transmission line library and add new record, change the name. So I'm drawing line 3 to 4. So in the problem the value will be 0.01, 0.03, 0.01, thermal rating will be 100. So just click update record, close this window, go to the structure reference number once again and you can find line T3 to 4. So change the MVA as 100, then update record. Right? So as in the picture I will show you. So we have drawn the line. So another two lines will be there. Line 4 to 5, then line 2 to 4. So I am going to draw the line 4 to 5. If we want to change the direction, so we can say rotate object. So if you click, so from bus, then to bus, so it will show another element ID. So the data for line 4 to 5 will be similar to line 1 to 3. So I am choosing line 1 to 3 because the data for line 1 to 3 and 4 to 5 are same. So once we have completed line 1 to 3, so I am choosing same value for 4 to 5. So click update record, line 4 to 5 will be over. Then we have to draw the line from 2 to 4. So for 2 to 4 we have to draw. So just click, so it will show from bus. So line 2 to 4 value will be same as line 2 to 3. So I am choosing line 2 to 3 value because it will be same as line 2 to 4. I am updating the record. So we have drawn the picture or draw this diagram as like in the picture. So this diagram we have completed. The bus diagram we have completed. We have to draw the generator as well as the load details of the particular buses. Right? So this will be the values we have taken now to draw the transmission lines. So from buses, so they have given Rx value as well as B value. So we have included these values and we have completed the drawing of transmission line. Then we have to draw the generating bus as well as load buses with this table. So say example for bus number 1, it will be one bus voltage will be 1.06. We have to draw a generator with voltage of 1.06. Say third bus, they have given bus voltages and they have given load. So there will be no generator in third bus, fourth bus and fifth bus. So considering second bus, you will have generator as well as load, right? So for solving or for drawing generator and load, we have to use this table 1.2, right? So for bus 1, they have not given any generation or load. It will be considered as slack bus, right? So the voltage will be 1.06. We are considering slack bus. Then they have given either generation or load. Based upon that, we have to draw generator or load. So first I am drawing a generator bus which is for bus 1. So for bus 1, I am drawing generator bus. So for that, you can see, so the generator icon will be here. So just click, and if you go, you can see the arrow mark. So we can able to change the direction. So change the direction, right? So now it will be in upwards. So just click at the bus, you will get generator will be placed that. So click OK. You will get generator data will be open. Now again we have to same thing like transmission line. Go to manufacturer reference number and choose any one. Click library. So once if it is open, you can see the values. Here you can add record. So just click add record. So here we can say change the name. So generator, I'm marking generator 11. So for this we have to include values. The MVA we have chosen will be 100. So MW we can fix it any value. So I'm choosing 80. KW rating we have chosen voltage of all the bus will be 220 kV. So I am choosing 220 kV. So in the problem for generator they have not given any values, R value, XD value, all the things they have not given. So just change it as 0 because they have not mentioned anything regarding your R value, XD value and XQ value for generator. Once if you complete this setup, click update record. Then close this button. So if you go again manufacturer reference number, you can find out. So here the generator 1 what we are entering, that value will be saved. Once if you choose if you look at the first bus, it will be a slack bus. So we have to give the voltage. So if you look at the problem, they have given the voltage will be 1.06. So change the voltage as 1.06. So once if you took 1.06, change it as 100, rated MVA will be 100, then click update record. So once if you updated, your generator will be placed at first bus. Then second generator which will be at second bus. So if you look at the problem, they have given bus 2 consists of your generator as well as load. So for bus 2 we have to draw a generator. So click generator, check the arrow direction. If you want you can change the arrow direction. So now the arrow is showing downwards. So I am clicking at that particular bus 2. So I am having the generator. So click OK. So again go to choose any generator. So go to library. So you can check if you want, you can add datas which will be given in the problem. So mostly for generator they will not give any values. So RA, XD, XEQs. So if they mention you can put, otherwise you can make it as 0. Just change MVA rating and KV rating based upon our requirement. So I just closing this. So we have already completed, we have chosen generator 11. So if you look out this bus 2 generator data, they have given a Q generation will be 30 MVR and or we can say the bus 2 will be of PQ bus because the load as well as generator data will they have given. So in the problem they have mentioned Q value will be 30 MVR. If you look at the problem, they will give generation MVR will be, just wait, I will show you. So if you look at, so here you can find for bus 2, generation MVR should be 30. So for PQ bus, your generator has to deliver or generate 30 MVAR compulsorily. So we have to put reactive power minimum and maximum should be 30. Then only it will be treated as your PQ bus, right? So the values remain same. So here reactive power and minimum and maximum should be 30, right? Once if you complete, click update record. So your bus generator 2 will be placed at this place. So once the placing of generator is complete, we have to place the loads. So go to the right corner. So you can see here this ground symbol like the structure shows load symbol. So click that. So come to the particular bus where we have to place the load. So for bus 3 I am placing, click bus 3, it says OK. It will shows only, it will ask real power and reactive power. So for bus 3 the load will be 45 and 15. Just put 45 and 15. That's enough. Just update record. Then add another load for bus 4. So for bus 4 in the problem they have given 40 and MVR will be 5. Just update record. Then for bus 5 they have given the value 60 and reactive power will be 10. Click update record. Then for bus 2 they have given 20 and 10. Just update record. So once if you complete this thing, we said, so this diagram will be completed in our MIPOWER platform with all the necessary data. So buses, transmission lines, generators, then loads, all this we have included. So we have to compute load flow analysis. Right. So in order to do the load flow analysis, just click solve button. You can see different things will be there. So in our thing we are going to look only load flow analysis and short circuit analysis. So this problem we are solving for load flow analysis. Just click load flow analysis. It will show a box. So in that box just click study info where you can find different load flow methodologies will be there. So Gauss Seidel, Newton Raphson and fast decoupled method. So I am choosing Gauss Seidel. So I am choosing acceleration factor is 1.4. Now if we want we can change the B tolerance or D tolerance, or you can leave that. So you can check here the number of iterations. If we want to do only one iteration we can replace it by 1, or if we want more number of iteration just replace. So like say 50 or 10 or 100, whatever you want, you can click number of iterations. Once if you complete, so you can see different other things that is not required. So you just fit only general, click OK. So once if you complete, just click execute button. So your load flow analysis will be done for the solved problem. Once if you have completed the execution, click the report button. So you can see it will ask standard, customized and IEEE, where you have to choose standard, then click OK. So you can get the output format file where we can view all the transmission line parameters. So this load flow will be solved by Gauss Seidel method for this problem. All the power generation voltages, all the things will be displayed in this load flow model. Right? So I'm having the answer for this. So for zone wise distribution, or say summary of result, my real power generation will be 169.24. So I am getting 169.24. So here you can check the total generation as well as load, right? So if we want, normally we will solve only one iteration at the time. So just change the number of iteration as 1 and execute the problem. So once if you do that and check the report, we can get for the values for only one iteration. So you can check. So check the values. If you want, you can check the different voltages values with their angle, right? So first bus will be of slack bus. So the voltage at slack bus will be 1.06. So that we have given. So angle will be 0. So because we have chosen that as slack bus, or we would say that will be as reference bus. So the value will be 0, right? So for other buses, if you compute and if you check, so these values must be same as what we have computed manually. So if we solve the load flow analysis problem manually, we can check the values with the help of MIPOWER by drawing the diagram, right? So once if you complete, so you just update or save as the record. So say as load flow analysis and you can close, right? So once if you complete, so this is how we have to draw the lines, towers, generators, loads, generator buses, transmission lines, buses in MyPower software, and we have to compute that diagram with the help of load flow analysis, right? So this is how we have to look for the solution with the help of MyPower software. So that's all about this class. So thank you.